Now, in the same way, use an XY chart to graph y equals 3 to the x. You should really go through this. You could just watch, but better to make this active, better to really own what's going on here. We're trying to deal with a new type of function. I want you to see what's going on with the numbers. Again, please make use of the fact this old formula about exponents. This formula deals with negative exponents. Okay, if you have a to the negative nth, that becomes 1 over a to the positive nth. Use that to fill in this table. You should get data that looks like this. And this graph looks more or less the same as what we were just looking at. So y equals 2 to the x looks very similar to this new one, y equals 3 to the x. This also models the growth of bacteria. It's just growing at a different rate now. So instead of doubling every hour, this bacteria triples every hour. Okay, let's compare the graphs of y equals 2 to the x and y equals 3 to the x, which we had really had the computer draw here so far, with y equals 4 to the x, the same idea, and then y equals e to the x. Okay, here's y equals 2 to the x in red. Y equals 3 to the x looks like this. Look at how this is taller in the first quadrant, but actually it is shorter, shallower in the second quadrant. And that's really because when you plug in like -1 for x, then you have 1/2 versus 1/3. Yeah, so you can actually see the data. Let's see, plugging in -1, you get 1/2 for the y value versus on the blue curve when you plug in -1. You have 3 to the -1, which is 1 over 3 to the +1, which is just 1 over 3. So that is this 0.3 repeating. So, what would you predict would happen if we turn on the graph of y equals 4 to the x? Okay, so I hope it's not too surprising that this y equals 4 to the x shown in green is taller in the first quadrant and then shallower in the second quadrant. Now what about y equals e to the x? Well, e is a number that's somewhere between 2 and 3. So e is just a fixed number. I know that e tends to freak people out, but because e is just a number that's between here, we can just do this. Since e is 2.7, roughly, hopefully it's not too surprising based on the fact that e is just a number, that the graph should be between the graph of e to the x should be between the graph of 2 to the x and the graph of 3 to the x, both in the first quadrant, and then again here in the second quadrant, how this purple is lying between the red and the blue. Again, e is just a number, so don't let this graph of e to the x throw you off any different from the graph of 2 to the x or the graph of 3 to the x. E is a very natural and useful number for some real biological phenomenon and financial phenomena and so on. That's why this appears. So, definition, given a fixed number called a, bigger than 0, and that number a is called the base. An exponential function is a function whose formula looks like this. F of x is equal to a to the x power. So, for example, y equals 2 to the x is an exponential function. Y equals 3 to the x is an exponential function. Y equals e to the x is also an exponential function. Please be careful. Sometimes people confuse 2 to the x versus x to the 2. These are different. And then when graphing each exponential function, you'll notice that the y-intercept is 1. There are no x-intercepts. There is a horizontal asymptote. The x-axis acts as a horizontal asymptote. The domain is all reals, or we could write this in interval notation as -infinity to +infinity. And the range is 0 to infinity, excluding the number 0. So please be careful. Sometimes people try to include 0 in the range, but actually, if you graph any of these, you will see that there is no point where the y coordinate is exactly 0. You can only have y values that are bigger than 0 in these exponential functions. So here's the thing. I want you to be familiar with how to graph y equals 3x plus 100, and graphing y equals x squared, and graphing y equals x cubed, and graphing y equals root x, graphing y equals absolute value of x. But now, to add to the list, you should also be able to graph y equals 2 to the x, and y equals e to the x, and y equals 3 to the x, y equals 4 to the x, those types of functions. So the blue ones here are new. These are the exponential functions. Everything else on the list should be familiar. These should be types of functions we've seen before. And with all of these, the idea is you should be practicing graphing these using the XY charts enough that you no longer need to rely on these XY charts. And the reason for that, for instance, is because you'll be expected to graph any of these and their graph transformations as well.